Hey everybody, John Grimsmo here. Today we're talking about Okamoto surface grinders. We've had this thing in the shop now for a couple weeks, and in this video we're going to deep dive into it. What we've learned in the past few weeks, some of the stuff we've ground, some of the challenges we've had and upgrades we've had to make already, and things that are going on. It's a really cool machine. I personally have no idea how to run it, which is kind of awesome. Angelo, however, has been getting really good at it, and he's going to walk me through this later, the things that he's learned. So later in the video we'll talk about that. At the moment the guys are busy installing our mist collector. We have we got this AeroX mist fit unit, the same thing we have on the Nakamura right there. We have a big one on the Swiss right there, and the Mori has one as well. So that's going to be good. It's going to suck up all the dust and the mist and the grinding stuff from the surface grinder. The other thing that is happening, this right here, notice the pole spacing. They're like, I don't know, ½ inch apart. It's a lot. And talking with a lot of surface grinding nerds and experts and things like that, for what we're doing, very flat, thin parts, a tighter pole spacing is better. I tried to order tighter pole spacing when I ordered the chuck, but they said it was 4 to 6 months out, and I'm like, but the grinder will be here in a week. I don't want to wait 6 months. So they said they can order me this one, and we'll run it until the new one comes in, and then they'll swap it out, which is really good of them. Except the new one is here. It came in like 2 weeks, or it was already in the States or something. I don't know. There's some miscommunication for sure. So the new chuck is coming in the next week or two, and then we're gonna have to swap it out, dress it down again, and make it nice, and then it should be better. Because with the big pole spacing, you basically, as far as I understand, you want as many poles as possible for the part that you're holding. And a lot of the parts we're holding could be really small. So it might only have 1 or 2 poles. A pole being a magnetic, like magnetism jumps from one pole up into the space and then down into the next pole. And the tighter poles, you get more grip. If you're holding a very tall part, the big pole spacing will shove the magnetic signal like high, something like that. But we're never doing tall parts. So yeah, lots going on. Let's get Angelo involved and let's talk about this thing. So one of the awesome things that we're using it for is these little squares. I need more props. Give me a second. Okay. Side note, these wheels, the rollerblade wheels that I put on my office chair are the greatest thing ever. These little plates, what they are AEBL steel, and they are going to be lock bar inserts for our knives. I've got some right here. Beautiful little thingies. We're using those on the Rask, and I am transitioning the Norseman over to lock bar inserts too, because they've been such a raging success on the Rask. So how I have been making them is in this window fixture, and this is a remnant. This is what's left over after making 4 lock bar fixtures. I love the concept of this. In practice though, it's not working so well. The material is theoretically flexing one way, flexing the other way. Thicknesses and dimensions are getting weird, and it's hard to keep it consistent. All 4 pieces are a little bit different. It's annoying. So I'm going to a flat lay fixture. The insert will go like this. It'll get clamped on. I've got side clamps around the outside. That way the back side stays flat basically. So we are flattening, we're surface grinding the back side. Now if you see, we've got, you can see some hopping this way and some, yeah. The wheel came mounted, the grinding wheel came mounted on the arbor. We haven't set up the balancer yet, but it came mounted and balanced, but how well balanced, I don't know yet. Obviously there's still a little hop, all the vertical lines this direction. And I found these lines using my magic stones here from Spencer at Kinetic Precision. I've talked about these before. He basically takes Norton stones, hand stones, whatever they're called, and then puts them on his surface grinder with a diamond wheel and then flattens them. And basically what you got a fine side and a coarse side, and you dress them together, and now they are ultra super flat. They're not abrasive, at all. If this goes onto a flat surface, it's not going to cut anything. But if there's a burr or a nick or a raised spot or a non-flat surface, then when you go like this, it'll show all of your secrets. So that's cool. So I've got a 4-inch set a while ago, and then I just got an 8-inch, 6-inch set for the surface grinder. So these big ones are going to live on the surface grinder. These little ones are mine. Yeah, just wanted to show you that. Thought that was pretty cool. So Angelo got some good practice in on the surface grinder doing these little coupons of AEBL. And he's getting tenths of thickness to his goal, and he'll just get better and better with more time and experience. And then, I mean, the other main application that we have for the surface grinder is the lapping machine right there, which is off right now because Steven has done his due diligence lapping for the day. When we buy the blade material, we buy it thicker. We used to send it out for double disc grinding, but now we're gonna do all the grinding ourselves in-house. We'll get more accurate thickness, we'll get flatter parts, we'll get better surface finish, etc. And then that will make Steven's job, that's not Steven, will make Steven's job easier on the lapping machine. And we've already seen it. He used to have a 45-minute lapping cycle, and now it is a 15-minute lapping cycle. Oh, awesome. So Steven and Angelo are both fine-tuning. Like, Angelo's like, how thick do you want the handle so that you have enough material to remove on the lapping machine to get through the gunk, but not too much that you're wasting time. They're doing that. It's going great. Things are awesome. The surface grinder came with the roughest grit wheel you can buy, as I'm told, a 46H wheel. So we might have to get some finer wheels. They're a couple $100 each, but you can start to see it. I don't know if you guys can see it in this shot, but in this orientation, you can see streaking that way. This is the grain direction. And after stoning it, it kind of shows it more. Not just the hops this way, but the streaks. A finer wheel is going to leave a better finish. So, might play with that. But all right, Angelo's got the Okamoto surface grinding all up and running. He's got a bunch of Rask blades on there right now. You know, I haven't run this machine, but he's become the expert at it, and he's told me some things, but this will be the good chance for him to deep dive and explain to me, like, really what's going on, and explain to you guys too. So, what's going on with this thing?
This is your grinder.
Yeah, I'm happy with this.
So yeah, we're going to be doing all our grinding in here for our blades to take them down from raw material to the thickness we want, more precision. Parts going on the kern it's very critical that it's that thickness, so this will help us achieve that. Bring it all in-house, stay vertically integrated. It's the way to do it.
So how's the machine been for you? We've had it running for what, 2-3 weeks now?
Yep, running 2-3 weeks. In the last week we started doing actual production batches. Right now we're doing some testing and trying to figure out our how much dressing we need on that specific wheel in order to get the finish we want. So just dialing that in. We did a few modifications to the machine in order to get the misfit up there. And so far it's working awesome. So right now we ground one side of these blades already. So they come from double disc. They'll have some variance in the thickness on top of their, you know, the flatness is off, unconstrained, we know that. The thickness is a bit of a variance through the double disc process. This will allow us to make them extremely, what would we do with that? They're not really gonna be flat, but they're gonna be extremely like parallel, yeah, exactly. Because it's a long piece. To get it unconstrained flatness, you gotta kind of shim it and play around with that a little bit, which we can do, and we've been doing it on a few things. So, but for now, this is perfect. So we basically just chuck it down, grind away.
And you were saying as you were putting them on, like even a speck of dust, like everything has to be clean. You didn't even want to keep them on the table for too long because little things.
Yeah. Once you've cleaned your setup with some rubbing alcohol, like 99% isopropanol is best. Clean the table with it, then you've got nothing on there. We've stoned them with these awesome stones that just skate all over the surface of that and make sure there's no little, you know, speck sticking up or, you know, any grit on there. Takes it right off. Clean it with some alcohol, lay them down. So yeah, even some fibers from lint from here will affect it. Anything, grit, dust. So parts come off, they should be clean, put right back on. And if they're gonna sit, you gotta clean them again, wipe them down, put them back on. So yeah, it all matters here. So yeah, now we're gonna do some grinding. So right now we've touched off, like we know where the other side is. The machine kind of knows it. It retracts up 10 thou. So it goes into a safe position above, so that way you could repeat jobs over and over if you had to. You can set that limit to wherever you want. So right now let's go and touch that off and see how it goes.
So this machine, being a CNC grinder basically, it can automatically dress the wheel and then do a bunch of passes and then dress the wheel again and do a bunch of passes. So you know you always have a fresh wheel depending on whatever settings you want, right? And is that feature worth it?
Yeah, it's awesome. Being able to not have to do that by hand. Like, I come from the tool and die world, and the grinder we had, it didn't have a Z travel, and it didn't have a table dresser, so we were manually dressing the top. You come down, you gotta find out where your zero is again, spark it, move. This is way easier, significantly easier. And being able to put it back to a position so the next job can go on with a known spot is going to be vital.
So it's always ready.
Yep.
So you've ground the first side to this height, and then you flip the blades, and the thickness should still be this height. So you just keep going, right?
Exactly. Yeah, there is some, error in the machine. Yes, the machine will start 1/10 higher. Sometimes it'll spark off on that 10th. So there is going to be a bit of variance, and that's where knowledge and skill of these machines come in that you have to kind of work with everything versus just like, oh, that's the number, go. Yes, yeah. Even the wheel itself is going to have variance from dress to dress. They're like molded wheels with a bonded, a bunch of particulates in there. It doesn't always dress perfectly the same, so I'll dress to get that perfect balance of the finish and your cut. You need to kind of play with that and find out what our wheel is. So that's what we're doing now. We're kind of finding the recipe for this wheel and specific to our material. Finding if we dress it a bit too fine, we get a bit of burn. If it's a bit too harsh, it's not the finish we want. So we kind of play with that, and you can set it all in here, and then saves it and run. So ready to start. So first things first. Right now we're 10 thou above our last position.
Okay.
So zero. Yeah. So if I go to zero, in theory, it's going to be right above that part. In reality, it's not. In reality, there's going to be some variance between the cut, the dressing, and its moves. So I'm going to give it a safety factor of about 5/10 and then walking down from there. So we're going to leave our coolant off for this because I kind of want to see what's happening a bit better. I'm going to keep my feeds a bit slow, and I'm going to start going back and forth and then walking this down. So I'm cross feeding in, so I'm above the part enough that once I start to spark off it, it's going to be Yep, going lower and lower. Yep. So in theory, zero is going to spark here. I'm not going to run down to that number.
You still got 2,000, so you're manually lowering it ever so slightly.
Because there could have been an error here. There could have been a piece of dust underneath. There could be, a burr that kicked up accidentally when we were loading it. There could be an error, and last thing you want to do is just assume it's good and run down to it and go. That's how you scrap parts. So right now we're going to slowly walk down. At about 5/10 is where I get concerned, and now I see I'm touching. See, just above that part.
I can't hear anything. Not really? My ears haven't been attuned to it yet.
So right above that part, 5/10.
Yeah.
So there's a cut.
I heard a cut, yeah. Just a little scuff,
You can see our difference there. We're 3/10 up and where it should have theoretically been. So there's a bit of variance there, and that's where skill and the experience comes in. So now I'm going to move it up to 5. So 3, we get 5/10 above that, so we're going to go up to 8.
Okay, so you're setting it to a vertical height, and then you're going to hit the cycle from there, and it'll start there?
And so if we were to try and chase this down into the tenths, you would probably have to take another measurement in this cut. So I flipped it, I'm theoretically there, but I know I'm cutting 3/10 above that.
Yeah.
So you could stone it, really make sure you're super clean, put it down, but you're still gonna have some variance in that, in your Z. So this is going to allow me to kind of set my zero again and then start over again versus just relying entirely on the controller. So from here, we're going to come over here. So now we know where our zero is roughly. We're going to go into our edit, and this is where we're going to take off our material. So I've got 1273, so I got 1 thou 3 tenths take off. So that's essentially and then I know I'm 3 above that. So I'm going to go, that's exactly the number I want to take off. That's my 1 thou 3 tenths plus my 3 tenths that I just moved up for safety. So there's my number. Now that's the rate it's going to go down. So now we're going to change the crossfeed over, hit that button. And just for anybody contemplating this machine, you can run this machine with that wheel not turning. So if you really want to make mistakes, this machine will definitely allow you to do that.
So like everything, you have to turn on the mist collector, you have to turn on the coolant, you have to turn on the wheel.
It will travel without that wheel.
Yeah. Whereas on a mill, you're just like cycle start, everything happens.
Yeah. Unless you forget that.
Yeah. All right, coolant on.
Now we get our coolant on. You got to get that right rate to flow through, not too much that you're going to this all moves in, it's a bit open so you can flood it. You need to have this cooling the diamond. The diamonds don't conduct heat, so it'll damage it if you try and run that all the time without actually cooling it. So allowing that coolant to be on there is going to give it a much longer life. So now we should be good. We're in a safe position. We're going to slow this down. Set our crossfeed. We can also change it to crossover. Yeah, the zigzag. That's going to give you a better finish, but we'll see.
Plus the minus
yeah,
everything.
Exactly. It also takes a lot longer, it seems like. Yeah. So yeah.
Okay.
But yeah. So far it's pretty.
So is it going to dress first always?
Yeah, I'll show you what it's going to do. So as soon as I start this,
so there's your cycle, start to finish, how much you're removing.
It's going to change all this, and you'll see what your cycle should be. So if we go back to our home, here is where we'll check our settings. So I know that on that last dress I had a bit of burning because we were going a bit slow. Oops, I got to be an edit for that. So we're going to speed up that dress. We're going to sacrifice the finish a tiny bit in order to achieve a more stable run. Yeah. So instead of 5, I'm going to move to 6. And we'll see what that does. Okay. And that's the speed it's going to dress that diamond across. So you go slower, and you're going to get a bit of a finer cut. You're going to dress it a bit smoother, and rougher is going to open up the pores a little bit, or open up your wheel and allow it to cut a bit more aggressively. So we're not necessarily changing the grit size because it's a 46H wheel, but you, in effect, are. So yeah, let's go.
So when it's dressing, does it kick a lot of crap like the...
Yeah, you'll see it. It's a heavier, the lighter stuff is getting picked up, but the heavier stuff is...
solid.
It's solid, some of it comes out. It's not, with the mist collector, it's much better. Okay. But they're there.
And the dressing is accurate so that it's keeping your 10th relationship.
Exactly.
So it'll take off a 10th or whatever, and it'll know now I'm a 10th smaller.
Yes, I believe we set it for 2 thou, so, and the finishing is a little different. So yeah, it'll basically take the 2 passes of dressing, come back, and now it's going to start to grind. And now if we hear a bad cut, you know you back out of that. And,
so watch it at the beginning.
Yeah. Now we should be just above the part by 3/10. And that means in the next cut that comes down, which is, it's going to come down in increments of 3/10. In that next cut, we'll be right on the part.
And how thick per pass?
3/10. So you can set that here. We had 4/10 with the rasp blade. We found that it was moving a little bit. Okay. So the 3/10.
So you're constantly playing with that balance between how aggressive you go, how fine you dress, how much magnetism, because this magnet is, you can change the strength of it.
We leave it on fully for the most part. You can also demag with it, although there is that residual magnetism, it still works. Yeah.
So I see the table is going left to right and then down a little bit and over again.
Yeah, it's going to drop on both sides.
And it'll do a whole, it'll face the whole plate, it'll drop down 3/10.
Yep, do it again. Yep. So over here, this is our cycle. So right now we're going to rough grind 7 times. It's going to do 3 times for that because it's going to move up 1/10 to skim pass right when it dresses. That's why it's added on an additional precision grinding. We're not going to bother with spark out for this part. We're not looking for that, so it's fine. And once it comes over this side, it'll drop, and then we're in the cut.
And it drops here and then goes back. It doesn't.
It'll drop on both sides.
Yeah. Yeah, so it's stepping down.
Yep, exactly. And there's different settings for that. You can plunge shift. You can make it just step down in 1 if you have a very small part, and you want to just come down on it. It'll do that. So now we're going to drop. So now we've dropped 3/10, and we should be in a cut now, like just on the part. We add that safety in just as a safety. We don't. You can take the risk, but there's no point here. You know, we're not going to gain anything from it. So, and you can hear we're on that part now, and you can see by the 1273 is still there. Next pass, it'll be gone.
And the coolant we're using, we put you put QualiChem 251 in this, right? Just like what's in all the other.
Exactly, same coolant. We go 4 to 5% with this.
Okay, so 4 to 5% being a lot lighter than the 7.8 we put in the other machines. Okay.
So yeah, we'll see how often we have to top it off. Luckily we have our awesome system here in order to maintain that balance. There are more specific cutting fluids, but this should do the job just fine.
Yeah, the QualiChem guys were telling me that you can buy specific grinding fluids, and he said like this will work fine. The grinding fluids have just a couple additives that help it maybe cut better or some life last longer or something. But he said it's fine with 251, so.
Having the same coolant in all the machines is valuable, yeah.
So then that 1.4 should go down.
Yeah. So see how we're 1273? Yeah. And that's our 1.4, so now we're probably going to be a 10th in variance. So.
Yeah, so that went down to 11 from 14.
Exactly, so now all of them should be getting cut.
What's the cycle take like for a whole?
I haven't timed a full, like depends on the size and how deep and all that, but not too long, probably like half an hour.
Like per side?
Yeah.
And do you have it to the point where you can set it and walk away, or is that?
Yeah, there was a few issues at first. That wasn't tight. I don't know if you want to talk about installers installing things, but basically that wasn't properly put on, and luckily we were here, but that thing basically spun on itself and dumped all over the floor, proceeding to just pour all the coolant on the floor. So we took it apart, put it back together properly, and we're going to do a fail-safe measure for it as well, so it can't rotate. That's probably the only complaint I have. Yeah, other than that, it's been great. The way they wire in the cabinet was awesome. Everything's ready to go. So we were able to essentially just plug in a misfit and then have a switch. Like, that's awesome.
Yeah, so mist collectors right here, on off.
Yeah, so we've got it plugged in right to the controller, buying our own misfit. So we didn't have to get the Okamoto mist collector for this system. So.
And then how's the whole paper band filter working out?
It looks like it's collecting a lot. So
yeah. You can see how much is collecting on. That's great.
It's a lot nicer than what I'm used to working on.
So it's clearly collecting wheel fragments and metal dust.
Yep, all the metal dust.
It's not dust that comes off of this, they're actual chips. Because the grain of the wheel, the grit, is like clawing the material away, and it's creating a little curly. But they're microscopic.
So probably really bad for your lungs, right? We kind of see that when you're milling the Torx patterns. It's hard, it just looks like swarf, and you look close and they're like chips. Like tiny, tiny, tiny little chips. But yeah, I guess you're cutting. So yeah, now we're in the cut. We got 8/10 to go.
Sweet. I can't really hear it.
Because we're only taking 3/10. Yeah. If I was to lower that to about 5/10 is when you really start to see sparks off of this.
I can see the magnetism of the poles is starting to collect stuff on top.
Yeah, it's kind of cool. And then that gets kind of pulled back in. It's not a big deal.
Not ideal, but not a big deal.
Yeah, it's just how it's going to go with the magnet.
How's the task light working out? Yeah,
I wouldn't mind some better lighting overall.
for sure. Yeah, we didn't light this corner very well.
Yeah, you lose a lot when you're out of that zone.
Yeah.
So we'll improve that. There's a few things we want to do. We're getting some walls put up for safety and for the environment, like our environment. And then, yeah, just more carts, more organization. We'll be setting up the wheel balancing setup on this surface table.
Right.
So yeah, that's 18 parts? Yeah, 18 parts.
I mean, it doesn't take that long. You're almost done already.
No, it's a setup.
Yeah.
Setup, making sure everything's good. Having that ear for it, like you'll hear the wheel when it's starting to get a bit burny. I recognize that noise immediately, even though it's been years since I've heard it. Just dialing it in.
So we did get the signal light, the green light on top. And has that been...
It's been useful because that way I can be over there, I can be at a meeting, I can be at the front of the shop, I can just peer back and see it.
Yeah, it's kind of in a beautiful, like, between all the machines where you can see it, you know, all the way across the shop.
Yeah, it's useful. And then it goes to orange and I know it's, I don't know, like when would it go to red? I guess if it overloaded and alarmed out probably. Let's hope we never see that.
But even just to give you that, like, you can be doing something else and be like, oh, it's still going, good to go.
Exactly, yeah. I look at that from across the shop and I look at that to make sure it hasn't spun around.
Yeah.
Until that thing's locked in place, I'll be a bit nervous. But it's great. Yeah, that way I can set it up. Once we get our recipes really dialed in to maximize the table space with the right dressing, all that, we should just be able to run it.
The other thing we got is we got the table mounted dresser as well as the top mounted dresser. Like, the machine comes with a top mounted dresser. Can you explain the difference?
Yeah, the difference is well, there's a huge difference in the way they operate. This is the typical, you know, dresser with your little crank wheel. The only difference here, because it's automated, it's actually driving a little cylinder with a latch and a gear, and that's actually what drives it forward, and you set the screw to determine how much you're actually going to bring it down. There's inaccuracies inherent in designs like this, just with where it actually is, whereas this is using the table travel itself at a very known position in order to dress it. So this is always going to be more accurate. So we're going to use this almost entirely. Where this will come into play is when we start to have parts on here that'll prevent you from coming and dressing. That's where that really comes into play. Okay. But as a mechanism itself, it just can't be as accurate. But it's still pretty damn accurate.
Yeah, it's still fine.
Yeah, that's what I'm used to. I'm used to manually doing that, manually picking everything up.
This can automatically do that one too.
Yes, yeah, you set between the two in this screen here. Okay. You can set which one you want to use, but for us, this is the most accurate. So yeah, now we're in our last.
So right now it just dressed for the finish pass.
No, we have three more rough passes remaining. So. And we'll change that too in order to get the most wheel life out of a wheel, how often we need to dress it, the depth of your dress, the speed, all that. Really define, because like as some of you guys might know, they're not all alike, even though it might be a 46H. I'm getting a Norton, it's going to be, you know, there's different bonds to them sometimes, different wheel manufacturers, so we want to find the best for us. And we'll probably have a couple of different wheels for different hardnesses would play a role. Like if right now we're grinding soft. If we're grinding hard, it's better to use a different wheel. You can use this wheel, you can dress it differently and use some techniques, but these are limited in their surface finish they're going to give you, and going to a bit of a finer grit, softer wheel would be allow us to get some really nice finishes on some hard stuff. But for now, this is awesome.
Yeah, there's a lot of variables to get really good results, right? And experience.
Yeah, it's experience value comes into play. Just the wheel itself, like you can, like we talked about, you can go down a rabbit hole balancing it. If I turn this wheel off because of all the coolant in there and let it sit for a minute, it's going to always come back to a spot.
The coolant's
going to pull inside of it.
And you might throw a balance.
Yeah, and then when you turn that wheel on, you got to spin it for 5 minutes. Like what'll happen is I can open this wheel, set us like let it, and it's actually going to set to a spot as if it's out of balance. You set that, turn the wheel on, go back, and it won't be there anymore. It'll just be gone. And every time you dress it, because it's a a bunch of grit bonded together. They're not all perfectly aligned or the same size or this.
So the weight distribution through the whole wheel.
It changes throughout the wheel ever so slightly.
Yeah.
So you balance it as good as you can to get it as good as you can going into the machine, and then it's going to slightly change in that. So sometimes you'll get a dress won't cut the same all the time. Plus you have your variances in material, carbide formation, all that. If you're cutting them hard, all plays a role. You know, but this will be nice. This is a really good steel. It's nice for grinding because it has a bit, you know, it's not like a really chunky carbide steel. So even though it's wear resistant with all the vanadium carbides you want, it's not going to be like cutting Vanadius 23, where you're like dressing that wheel on every pass. So.
And we're grinding these blades soft. They're not heat treated yet.
Not heat treated yet. So it's, yeah, this is basically stainless tool steel. That's what it is. You know, you got a high alloy, a lot of different elements in there to make your carbides and create solutions. So, yeah.
Yeah, and we're already seeing the benefits of the consistency of having these blades be 126 plus or minus 2/10. When we put it on the machine, now the chamfers, the double corner rounder, all the engravings, the features, they're so much more consistent on both the Kern and the Mori on the Norseman.
And then to lapping. So we'll be able to reduce our lapping time by about half an hour per side, which is considerable considering the volume it hits. So.
Yeah, so this gives us so much more consistency in our production process downstream. Saves time, everything.
Just higher quality. And bringing it in-house keeps us more, like we say, vertically integrated.
Yeah. Like we get to control it. Yes. We like to control.
We're the in-house knife manufacturer. Yeah. The in-house knife manufacturer. Yeah, so keeping it almost entirely vertically integrated for us is going to allow us to chase, you know, every little issue we can.
Yeah, it's. I thought I would have heard it more, like. Meh,
meh. You can, like if you try to cut more, like 3/10 is light. Yeah. It's super light, but because we can just walk away from it, it's nice. And it's safer, you don't need to worry about it.
Very cool.
Also with these, you've now got all the engraving on the spine. And they're being engraved soft, so you know, how thick they are matters a lot, so that they can always be right on the center within a few tenths. So now the dress is going to be a slow dress for the finishing pass. What it does is slows down the wheel to the required speed of 1500 RPM in order to dress. Yeah. So yeah, the RPM for dressing is different. We took these specs from Okamoto for the max speed and the dressing speed.
That's way slower.
Yes.
And as you said, there's a limit. You know, you want to go super fine to get the best finish, but if you go too fine, you're going to burn the blades, right?
Exactly. So, and it gets really hard when these are hardened. Once you start doing like hardened high carbide steels, it could become a nightmare where you're in the middle of a grind and your wheel's burning up, and now you got to abort, get it back, start over again. And anybody who's ground before, the last thing you want to do is stop a wheel on a part. You're going to cut right into it. So it bumps up a tenth. You can change the setting, but it goes up a tenth to give it a safety. So it kind of adds a bit of time, but it's safety.
Yeah, it's in the when Saunders toured at Orange Vice, he had a great video about that. They have a bunch of Okamoto surface grinders. Yeah. His entire goal is process reliability. Yeah. He's like, I will run slower so that I can walk away.
Exactly. Yeah, and we learned that with everything we do now. Yeah. There's certain things it's like it just isn't worth the risk of it being quick. Where it's, you know, seems fun when you get it, but then it just adds the risk mitigation is, you know, is huge now. Or lack thereof.
We're trying to build everything here to do as much as possible with a relatively low amount of people. Yeah. We don't need somebody standing here 8 hours a day.
No, we need high quality work, you know, things thought through well. We're tracked and we're done. Cycle's done. I can now move this back. So I know I'm above my grinding, my table. I'm above the diamonds. So now, 10th out, so I can just grind.
So you can go over. Not going to hit anything. Yeah, and Angelo reminded me that these blades, we did get them double disc ground, which we've always done. So they're 128 maybe?
Yeah, 1274 to 128.
So 1274 with not the flattest surfaces. So we're only taking off a thou 3 or whatever to 126. But as once these are done, we're currently getting the next batch water jet cut right now, and they're going to be like 156. So they're quite a bit thicker. But as you said, it's just automated, so it will be a longer cycle, but we still just walk away and grind it down.
Should be great. And if we're doing, 20 a day, we should be able to get our month's worth of production in a bit. So this is done now. I'm demagging it, so they're demagged, so now they can pull off. So now we can get one off.
So they're still tight on.
They're still a bit tight on. It is like, there's ways to get them off. You just slide it typically just to get it off. That you will get some micro scratching, but it's not the end of the world. Yeah, so we want to get a gun here, like tied into this, so we can utilize it in order to rinse these off, because there's going to be all this sludge on it, all the grinding dust. So yeah, we're going to take this off, take a measurement on it. There's ways to measure it when the chuck is on, and if you're going for that 10th, I might do that. But
because once you pull it out, once you demag it, like the whole thing has to be clean again.
Yeah, you've introduced, more than likely introduced particulates underneath the piece. Not where you if you were just to go off on, you're gonna like have a different size. Yeah, almost guaranteed.
And we're trying to eliminate things like taper or waviness or whatever. It's going pretty good.
So I'm just gonna use some of this coolant in order to, that way I'm using the same coolant, so there's no risk of introducing any weird materials into here.
So I noticed you still have the wheel on. That's
Yes.
Normal surface grinder practice.
100% leave that on. Yeah, I would not turn that off while I'm still have potential of going back into my work. Yeah. Yeah, if you turn that back on, you redress it again, you're back to zero. So, I mean, it's going to dress every time, but it's just the standard.
126, 15.
Yeah, and we're looking for plus or minus a 10th. So, if we really wanted to get that 10th, we could get it, but
yeah,
waste some time.
there's a point where it's fine, and then there's a point where you're like, next time I'll, maybe take off a 10th and see what happens.
But that's within range, so we're good. Yeah, and if we really wanted to get these, like, so you can see that banding there.
Yeah.
If you wanted to get these perfect, there's flatness that's constrained, flatness that's unconstrained. Right now these are flat constrained theoretically, but not flat unconstrained, and we can go more into that maybe when we're doing the lock bar insert pieces, showing how we shim. Always more to talk about.
There's always more to talk about, but that's what future videos are for. Yeah, okay, we'll cut it there, guys. Hope you enjoyed the surface grinder deep dive. I've certainly enjoyed having Angelo surface grind parts for us. It's going great.
Yeah, I mean, it's been a while since I've been on a grinder. When you're tool and die, you're generally grinding a lot.
Yeah.
So it's kind of nice to go back to those roots and have a much nicer machine to do it on. Yeah. Having to chase those tenths, even millionths, in some instances on a grinder that was not nearly as nice as this was a headache. So this is going to be a dream.
Yeah, this lets us add that whole next level of precision, the next layer, lets us control more features of the parts coming to you guys. And I like control. It's pretty good. So yeah, thanks for watching, guys, and we'll see you in future videos. Later.